Alright, so chemical equilibrium. So equilibrium is a closed system where the opposing reactions occur at the same rate. The rate of the forward reaction is going to be equal to the rate of the reverse reaction. So the rate of formation of products from reactants will be equal to the rate of formation for reactants from products. At equilibrium, the concentration of reactant and product don't change. Equilibrium is also dynamic, which means that it has a double arrow. At equilibrium, keep in mind that the concentration of reactant is not necessarily equal to the concentration of product. You can reach equilibrium regardless of where the reaction begins. So you can first begin with reactant only, or with product only, or with a combination of both reactant and product. You can still reach equilibrium any one of these ways. So there are two ways that you can find equilibrium, and the first one is kinetics. So kinetics is just the rate of reaction. So at the equilibrium point, the rate of your forward reaction will be equal to the rate of your reverse reaction. Second way is concentration. At equilibrium, the concentration of reactant and product don't change. The concentration of reactants will decrease as the reaction proceeds, and the concentration of product will increase as the reaction proceeds. And if you just think about it, it'll make sense because the product will obviously increase as you proceed through a reaction. So the law of mass action. This basically is the relationship between the reactants and products concentration at equilibrium. So the coefficients of different reagents, products, or reactants in the balanced chemical equation become the exponents in the expression. And you can find the equilibrium constant expression by dividing the concentration of the product over the concentration of reactant. So generally, if you had the equation A plus B is the equilibrium with C plus D, where your lowercase letters are your coefficients and your uppercase letters are your reactants or products, you would find the equilibrium constant by dividing the concentration of product over the concentration of reactant. And you know that whenever you're doing this, you have to raise the concentration to the power of your coefficients. Notice how I raised the concentration of C to the coefficient of lowercase c because that was the coefficient, and the same thing with D, A, and B. And that's going to give you your equilibrium constant KEQ. So there are a couple ways that KEQ is expressed, and here are two of them. So Kc is used for the concentration in molarity, and Kp is used for pressure in gases. So KEQ is basically the equilibrium constant. So what is it though? So at equilibrium, the ratio of concentration to or pressure in terms of products to reactants is a constant, and that's KEQ. KEQ is independent of the initial concentration of reactant or product at a given temperature, but it does depend on the concentration or pressure at equilibrium. It depends on the stoichiometric ratios of reaction, not the mechanism. So this is what I mean when I said that you can start from any point in the reaction and still reach equilibrium, and your KEQ will still be the same. Most importantly, the KEQ expression only includes the reagents participating in the reaction. It only includes gases and aqueous solutions, not liquids or solid, and we'll see what that means later on in the video. So KEQ has no units. As the KEQ decreases, the concentration of reactants is more than the concentration of products. So you know that reaction favors the left, and it wants to stay in its molecular form. As the KEQ increases, you know that the concentration of products is more than that of reactants, so the right is favored. If you want to find the KEQ for the reverse direction, you will find it as 1 over the KEQ of the forward or the reciprocal. You might notice that when you were doing Hess's law and you were doing enthalpy, the enthalpy for the reverse reaction was the negative of the forward reaction. But however, when you're dealing with KEQ, you find the reciprocal. So just keep that in mind when you're dealing with KEQ. So when you're changing reactions, like changing the stoichiometry or using a reaction mechanism, the KEQ will also change. If you multiply a reaction by a coefficient, the new KEQ is calculated by raising the original KEQ to the power of that coefficient. And when you're having a reaction mechanism, the overall KEQ is the product of the KEQ of each of the individual steps of the mechanism. This is multiplication. Notice how in your Hess's law, when you're finding the reaction mechanism of the enthalpy, you are adding the enthalpy from each step. But for KEQ, you're going to be multiplying this. So now let's go over some questions for the law of mass action and equilibrium constant KEQ. So question 1, express in terms of Kc, N2 plus 3H2 is in equilibrium with 2NH3. So just pause the video here and work it out on your own, and we'll go over it in the next slide. So the Kc in this case is going to be equal to the concentration of NH3 ammonia squared over the concentration of nitrogen gas times the concentration of hydrogen gas cubed. Notice how the powers that we're raising each reagent to. In this case, for ammonia, we raised it to the power of 2 because that was the coefficient of the product ammonia in the original balanced chemical equation. We're also raising the hydrogen gas to a coefficient of 3 because that was our coefficient in the original equation. Notice how if you're not given an equation that's already balanced for your question, you will have to balance that and take those coefficients into account when you're raising the reagents to a certain power for your Kc expression. Question 2. Find the Kc and the Kp of this reaction. Calcium carbonate is in equilibrium with calcium oxide and carbon dioxide. So the Kc for this reaction is going to be the concentration of CO2, and the Kp is going to be the pressure of CO2. Notice how this expression only includes the CO2, carbon dioxide gas. It does not include the calcium carbonate solid or the calcium oxide solid. And this is because, as I mentioned before, the equilibrium constant does not involve solids or liquids. It only involves gases and aqueous solutions. So if you ever have a solid or a liquid in your balanced chemical equation, you can essentially disregard it for the purpose of KEQ. Question 3. Find the KEQ given the following information. N2O4 is in equilibrium with 2NO2 and your KEQ is 0.212. Find the KEQ for the following reaction. 2NO2 is in equilibrium with N2O4. For this question, you notice that what you did in this question is just flipping the equation. What you did is just, instead of going forward, the forward reaction, you're finding the reverse reaction. So you're just going to find the reciprocal of the KEQ for the first reaction. It's going to be 1 divided by 0.212, which is equal to 4.72 with 3 sig figs. And notice how you were finding the reciprocal. As I mentioned before, in Hess's law, when you were finding the reverse reaction's enthalpy, you found the negative, but you're finding the reciprocal here. So it's really important to keep in mind the differences between the equilibrium constant and the enthalpy formulas. And question 4. Find the overall K given the following mechanism. So it's a two-step mechanism. 2NO plus Br2 is in equilibrium with 2NOBr, where your K is equal to K1. Second equation would be Br2 plus Cl2 is in equilibrium with 2BrCl, and your K is equal to K2. So let's go over the answer now. So in this case, you'll notice how we multiplied the first equation by -1. All this means that we were just flipping the reaction to go from products to reactants, and since it's in equilibrium, it doesn't really matter. So when you're finding the K for this new reaction, the K value is no longer K1. It's the reciprocal of that, 1 over K1. We're also going to be canceling out the intermediate of Br2. Since it appears in the products for reaction 1 and the reactants in equation 2, we can just cancel those out to get our overall equation of 2NOBr plus Cl2 is in equilibrium with 2NO plus 2BrCl. And when we're going to be finding our overall K, we're going to be multiplying the K from both of these two reactions. So 1 over K1 times K2. And that's going to give us K2 divided by K1 as our final answer for the overall K of this reaction mechanism. So thank you for watching this educational video on equilibrium and the equilibrium constants, KEQ, and if you have any questions, feel free to comment them down below. Thank you.